Well, thank you so much. I'm really excited to be here today. Most of the time when I get asked to talk, it's about all of the new things that we're doing. This is the first time where I've actually had an opportunity to go back and talk about the things that we've done in the past. So I'm going to go back about 6 years and talk about how we made one of our programs CS First at Google. And this is a lightning talk, so I'm going to cover about 6 years in 20 minutes. So I apologize for how fast I'm going to move, but I'll try to leave a few minutes at the end to capture a few questions. So to set the stage for this work, in 2011, about 43,000 students in the US earned a bachelor's degree in computer science. And that number was a 25% drop from where that was in 2004. So to put that into perspective, at the time, there were about 365,000 students getting business degrees. There were 36,000 students getting parks, recreation, leisure, and fitness studies degrees. And not only is this a small number, but only 20% of these students were from underrepresented racial groups, and only 20% of these students were female. So not only are we not getting enough students with these undergraduate computer science degrees, but it is far, far and away white and male students getting these degrees. So at the time, again, 2011, Google was about 13 or 14 years old, and they were hiring thousands of computer scientists every year. So this number is a crisis for the industry. It's not just Google. It's everybody in computer science, in tech, that cannot hire all of the computer scientists that they need. And this isn't some long, far-out horizon that we're talking about. This is a crisis of the future of work that is starting right now. So Google panicked. And as was fashion at the time, they started up a bunch of programs to try to solve the problem. So we had CS for HS, which was a professional development program. We had CS in Media, which worked to influence TV, movies, film, to introduce positive representations of computer scientists or of computer science. We had a research team that was working with Gallup on publishing research about computer science education. So they were going to tackle this from every possible angle, which is where I came in, and I'm sitting there somewhere in the back. So at this time, they hired a group of teachers and computer scientists to teach computer science in South Carolina, which might sound weird, and it is, but I had a job, so I wasn't complaining. And so, while it might seem like a strange way to start a program to solve this problem of not having enough students going into computer science, the problems were really deep. So there's a 2010 ACM report called Running on Empty, and they found fewer than 1/3 of states had comprehensive CS standards, and there were almost no teacher certification programs for CS. So at the time, computer science was basically being treated like woodworking in schools. And for Google to actually affect change here, there weren't a lot of levers for them to pull. You know, they couldn't just dump money into, or into programs. They said, well, let's hire some teachers and see what we can do. And so we learned how to teach computer science. So this is us in a conference room learning how to teach computer science. And then we went out into the local community and we tried to teach it. And so to set the stage here, this is about 2013. This is post No Child Left Behind. Everything was getting very structured and rigid within education. So, you write your learning objectives on the board. You practice all the procedures in your classroom, like how to pass out papers as quickly as you can. And at the time, existing programs in computer science education mirrored these perspectives. So in the industry, we like to call them like puzzle-based programming. And so you have simple learning objectives, like sequence some blocks to have a character go through a maze. And then the lessons basically scaffold up through levels until students have successfully accomplished that learning objective. So I'll never forget one of the first times I ever did this. I was in a 4th and 5th grade classroom in North Charleston, South Carolina. It was after school program. Kids had already been in school for 8 hours. I was like, all right, we're going to do this. It's computer science. It's super fun. You all are going to love it. 5 minutes in, I had a student crying. And so, I used to teach 4th and 5th grade. I've had students cry before. I'm used to it. This was the first time where I designed a lesson that made a student cry. And so, the reasons were clear. It's levels that students have these challenges that they need to work through. So other kids were moving forward. They weren't moving forward. They didn't know how to move forward, and so they did what is natural. They're like, well, I'm just going to cry. And so this didn't mesh with our team's goals. So we were trying to get students into computer science, and it was very obvious that crying students weren't the path to us doing that. And so to make an analogy for what we were thinking about, so this was sort of like if you're trying to teach a student to read, and you're like, all right, we're going to start with phonics, like all the phonemic building blocks, but that student's never been read a book, they've never seen written text. Like, that's basically what we were dealing with computer science. Like, students had no context to understand anything about computer science. And so it doesn't matter how much rigor we are throwing at students. Learning is about context. It's about making connections. And without having any of that set up, like, these students weren't in a place where they could actually learn any of those learning objectives that we're trying to throw at them. And so you'll never guess what we did. We're like, none of this stuff works. We're going to make our own thing. And so, because this is a lightning talk, this is where I have to start going really fast about all of the things that we did. So this is a screenshot of our website in September of 2014. And when I first looked at this for this presentation, I'm like, I can't believe they let us put this out. Like it's unbelievable. Like, we weren't on a Google domain. Like, this wasn't built on any like Google backend. Like, we just made a website. We put it out there. And we're very proudly saying that we have 1,200 students that have gone through our programs. And so what we decided to do was, instead of focusing on really narrow learning objectives, we were just going to try to get kids excited about computer science. So we focused on making it creative. We wanted to demonstrate all of the different things that you could do with coding. And most of all, we wanted to make sure that every student that went through our program felt like they were successful. And so, jumping forward, this is what our website looks like in January of 2015. We decided to base our curriculum around the idea of themes. So we have like game design, art, fashion, storytelling. So we're trying to meet students where they were. We're trying to connect to context, things that interested them. And so this was very much different than anything that existed in the field, which was pretty scary for us. So there are the folks that were very structured, focused on the Computer Science Teacher Association standards. Here are our learning objectives, are students meeting those? Then there were people on the other end that were like, computer science is creative. It's like a bunch of building blocks, dump them out on the floor, see what kids can make. And we were not even really in between those. We were somewhere else where we had built a ton of structure for our program, focusing on making students successful and developing context for what they were learning. We weren't necessarily doing that aligned to CSTA learning objectives. We also weren't really doing that like, go see whatever you can do. And so jumping forward to where the program is today, so we've been used by, I don't know what the exact number is today, but I think it's like 2.5 million students have gone through our programs. We designed everything for ages 4 through 8. There were a ton of reasons for that. But one of it was just like, these are identity building years for students. We figured if we were going to actually help them develop context for what computer science was, these were really the ages to reach them. We made everything that we do freely available. And it's not even behind like a sign-up wall. So teachers can go to our website, they can access all of our curriculum for free. And we only designed this initially for South Carolina, which is where we were based. And then eventually like scaled out through the country. Now we're in 75 plus countries. We've had people localize our content. We've localized some of our content. So like I said, we have a bunch of structure for our lessons. And so we recognize that there are very few trained computer science teachers. And so we needed a solution that was structured for students, but it was also structured for teachers. So we went with a blended learning model. Students watch videos to complete projects. It's self-paced. It ensures a high level of success for students. And it's very, very easy for teachers to implement, which is one of the reasons why I think we've been as successful as we have. And so one of the other decisions that we made, which is probably one of the most critical things that we did, was in selecting a platform for students to code in. And so we selected Scratch, and if anyone knows anything about computer science education, you've probably seen Scratch before. It's block-based coding, and again, this just reinforces all of our own team's beliefs about how students should learn how to code. So high rates of success, it's fun, it's creative, it's not necessarily a stereotypical view of what computer science is. Like, this is the new platform up here, but this looks fun. It's not like the dark screen with like the green text and somebody in a dark room typing it all in. So It's fun. It matches, again, sort of the beliefs of our program. We went down the theme route. Today we have 7 themes for our curriculum. We have about 800 instructional videos. So actually to put together all of this curriculum took a ton and a ton of work. We also have standalone lessons. So if anybody in here has ever heard of the Hour of Code, we participate in that every year. We have a new lesson. If you've done it before, we have like create your own Google logo. I don't know if anybody's ever seen that. So done a bunch with that. And this is to support teachers that are like, you know what, I want one interaction. I don't want to do like a whole club. I just want to show this to my students. And more recently, we've been developing lessons to integrate into English language arts classes. So again, it's taking the ethos of like, all right, like let's show kids what computer science is. Let's get them to create something. Let's find out how to meet them where they are. And so here are sort of all of the principles that we built the curriculum on: courage, confidence, perseverance, impact, sense of belonging. And those are really the things we emphasize. So the things within the affective domain, we're really pretty far away from necessarily like the Computer Science Teacher Association standards of like, you're gonna learn how to sequence, you're gonna learn loops, all of those things. So to close out, so that stat I gave at the beginning, the 43,000 students in 2011, a lot happened right after that point. So code.org started up in 2012. There was a boom in curriculum development. So startups happened all over. They were saying like, all right, this is a big problem. Let's see what we can do. Academia jumped in a big way. CSTA grew their membership by a ton. There was a movement to create a K-12 CS framework, which then influenced state standards development. College Board launched AP Computer Science Principles, which is a phenomenally successful course at providing access to computer science education. It's like relatively inclusive. It's like the most inclusive thing that's come out. So tons of things have happened. It was a systems problem. There's been a systems solution. The most recent figure, 2017, there were 71,420 graduates, which is about double that lowest figure, which was in the late 2000s. So since then, in those 6 years, our program had about 2.5 million students use it, and that continues to go up. And so at the beginning of the presentation, I talked a little bit about that crying student and how we try to take a different approach. And so to close out, I want to share a tweet that I think demonstrates the difference of our program. And so this is from a librarian. We just found this on Twitter. And like they had like a little exit ticket thing, and it was like, what did you learn today? And so, you know, you go back to being a teacher, like, all right, like the thing you learned is the learning objective. And this student, who is a girl, which I think is important here, says that girls can do things. We're like, oh, that's exactly what we were trying to do. Well, thank you all so much.